Sometimes it's the components we barely notice that are really doing the heavy lifting in our tech.
Definitely.
Take the relay. On the surface, it seems simple enough, just an electrically operated switch. But when you kind of dig a little deeper,
Yeah.
you find this truly fundamental piece of engineering. And it's used in just an astonishing range of places.
Absolutely. And what's fascinating, I think, is how this seemingly basic device underpins so many complex systems.
Right.
So for this deep dive, our mission really is to get to grips with the core principles, what makes a relay tick, explore its diverse uses, and understand why it's still so crucial even today with all our advanced tech.
And to do that, we've been diving into some really interesting material. We've got excerpts here from an engineering document. It's just titled RMELAS.pdf. Pretty straightforward.
Yep, gets right to the point.
Okay, so let's unpack this. The document emphasizes that the most common type, the one you'll see most often, is the electromechanical relay, or EMR. What's actually going on inside one of these?
Well, at its heart, the EMR uses electromagnetism. That's the interaction between electricity and magnetic fields, basically.
Okay.
You've got an energizing coil. Think of it as just wire wound around a permeable iron core.
Right, like a little electromagnet.
Exactly. And this core setup has a fixed part, they call it the yoke, and then there's a movable part, the armature. And that armature is held in place by a spring.
Right, so it's like a tiny magnetic tug-of-war is set up inside
Yeah.
the device. When we send a low-voltage signal, AC or DC it says here, to that coil,
Yeah.
what happens then?
Well, that current flowing through the coil creates a magnetic flux, a magnetic field.
Okay.
And this field generates a mechanical pulling force. It's strong enough to overcome that spring's resistance, and it physically moves the armature.
Ah, okay.
And here's where it gets really interesting. This physical movement,